Hello chemistry students. In this video I'm going to go over solution concentration and molarity. So solutions are mixtures, which means that they have variable compositions, and that makes it necessary for us to express the strength or the concentration in some kind of measured way that we can put a numerical quantity on, and that's what this presentation is going to be all about. Right, so let's go back and just talk about a couple of things. So concentration is a way to measure the amount of solute dissolved in a solution. A dilute solution is a solution that contains less solute per volume than a concentrated solution. It's kind of a general or generic term that doesn't have any kind of specific meaning, but generally speaking, you would take a dilute solution to be something that's not very concentrated, and then a concentrated solution is going to be a solution that contains a large amount of solute per volume. And you probably heard those terms, at least concentrated, in maybe buying a juice concentrate or something like that, where there's a lot of stuff in a small space and you have to add water to it before you use it. Alright, so the main concentration unit that we'll use in chemistry is molarity. And as you can see, the name comes from moles. It's calculated by taking the moles of solute and dividing it by the liters of solution. So the formula is molarity equals moles of solute divided by liters of solution. And that's the equation that we'll use to do most of these calculations. Alright, so here's an example. Suppose that we had 1 mole of sucrose, and that's table sugar, by the way, and we mixed it with some water. So it would dissolve and make sugar water. So if we were to keep adding until we got to a volume of exactly 1 liter of solution, what would be the molarity of this solution? Alright, so our unknown is molarity. Our known is that we have 1 mole of sucrose, and we dissolve it such that we have a total volume of 1 liter of solution. The plan would be to use the equation molarity equals moles of solute divided by liters of solution. And so we would divide 1 mole by 1 liter of solution, and we would get an answer of 1.00 molar. Okay, and that's how you say molarity. Or you could say moles per liter. So 1.00 moles per liter, or 1.00 molar is how you would say that. Okay, and this summarizes that, so 1.00 molar. The question you might ask is, hey, how do I make a solution like this? Well, the basic process for this is you would weigh out the known or needed quantity of the solid. If it's a solid solute, we'll deal with liquids in a little while. And you would have a volumetric flask of a certain volume. So you'd add the solid to that, and then add your solvent. In this picture they're using ethanol. Most of the solutions we make are water-based. And you keep adding, so you mix, and then you keep adding water until you get to the mark, and that would be how you would get a solution volume of exactly the needed quantity. In this case, it's 500 milliliters. By the way, it would be incorrect for you to say that there's 500 milliliters of water in here. There's probably actually a little bit less than 500 milliliters of water. The thing that's important with molarity is the volume of the solution, which includes both the water and the solute. Alright, here's our second molarity example. If you want to, you can pause it and work it out yourself and then come back. So what is the molarity when 0.750 moles is dissolved in 2.50 liters of solution? So our unknown is the molarity. Our knowns are the moles and the liters. So our plan will be to use molarity equals moles over liters and solve to get a final answer of 0.03 molar. Alright, here's another one. Right, let's say that you had 58.44 grams of sodium chloride and you dissolve it in exactly 2 liters of solution. What would be the molarity of the solution? So we're starting with grams this time. So our plan here is we're going to have to convert. You list your known and your unknown and your own. But our plan is going to be to convert the grams to moles and then use the molarity equation. So let's do that. And conveniently, you know, when chemistry teachers work stuff out, sometimes they make it easy. So when you convert to grams, notice, hey, this is the molar mass. Well, that means you have 1 mole. Okay, so 1 mole divided by 2 liters of solution is a 0.500 molar solution. All right, give this one a try. And then pause. And here's the answer. All right, here's another problem. This one asks you to solve for the volume. So this time you'll have to do a little bit of algebra to solve for the volume. When you plug into the molarity equation, you'll need to convert the 80 grams of glucose, convert that to moles. You're given the concentration, so it'll be 0.5 equals, I think 80 is going to end up being about half a mole, and then divided by the volume, and you'll have to solve for the volume. You should get 0.889 when you're done. All right, so I already discussed this, but molarity is referring to the volume of the solution, not the volume of the water or the solvent added. All right, here's another one. We're going to look at dilutions. This is another way of preparing a solution. So instead of mixing a solid into a liquid, which is what most of the happens with most of the molarity equations, we're going to mix 2 liquids, maybe one that's already been prepared, and adding water to it to make a less concentrated solution. This is something I commonly do as a teacher preparing for labs when I have to make a certain concentration of an acid. Okay. So diluting something means that you add more solvent, usually water, without the addition of more solute. So that means that the number of moles before is equal to the number of moles afterwards. And if you take the equation for molarity and you solve it for moles, you'll get molarity times volume equals moles. Since the moles is staying the same, then the molarity times the volume to begin with is equal to the molarity times the volume at the end, or M1V1 equals M2V2. All right, so here's a dilution example problem. So we've got 53.4 milliliters of a 1.5 molar solution of sodium chloride, but you need some 0.8 molar solution. How many milliliters of the 0.8 molar solution can you make? So here's your unknown. You want to know the final volume of 0.8 molar, and then you know that you started with 53.4 milliliters of 1.5 molar sodium chloride. So you can set up your plan here. Anytime you have like a change in volume or change in concentration, that's your trigger to know that you need to do a dilution equation instead of a molarity equation. So M1V1 equals M2V2. Plug in the quantities that you know. If you read this and apply your reading comprehension skills, you should be able to tell this is what you start with and then the other is what you end with. So that's what would make these the M1 and the V1 and these the M2 and the V2. Divide both sides by 0.8 to solve for V2. You should get about 100 milliliters. All right, a good question to ask here might be, hey, how does that one work? So the way that you make a dilution is you may have a solution of known concentration. So you draw out an exact amount of this. Doesn't show here, but maybe 25 milliliters of it. Put that into an empty flask. Then you add water to it until you get to a predetermined final volume. So you can see that it works out that the amount of moles would be contained in this volumetric pipette. So that would be your volume that you started with, and it would have whatever molarity the stock solution had, and then it would be the same number of moles, the same amount of blue stuff is still in this diluted solution, but its concentration is diluted now because it has a larger volume. So hopefully that helps you visualize what's going on. Alright, here's a second dilution example. This is something that I've probably done maybe more than once in getting ready for a lab, or certainly things very similar, maybe this exact calculation before. So how much concentrated 12 molar hydrochloric acid is needed to prepare 100 milliliters of a 2 molar solution? So let's list off our unknown, which is we want to know the initial volume, how much of that concentrated solution do we need, and we know that we want to prepare 100 milliliters of 2 molar, and we're starting with 12 molar. So way to check yourself, you know that the initial volume is going to be certainly less than 100 milliliters because that's our final solution volume. So we have a change in something, change in concentration here. So if you have a change in concentration or change in volume, you use M1V1 equals M2V2 and plug in the numbers that you know. It'll end up being 2 times 100, so 200 divided by 12, and you should come out with about 16.7 milliliters when you perform the calculation. Thanks for watching.